Guys, welcome to our YouTube channel Mainframe Girls. Today we'll discuss about a basic term which we use in a mainframe, that is a dataset. I'll explain you how we use a dataset in our JCL coding, how a dataset has been stored, which type of datasets are there, how many ways we can create a dataset, and many more. Okay, we'll see the definition of dataset. Dataset is nothing but just a file where we store all the programs, the codes, everywhere. But how it is stored? Dataset is collection of logical records and which are organized in a block structures, and where it is stored in a storage in which there are many types of storage, which is a primary storage and a secondary storage. So a primary storage can be a RAM, the virtual memory and everything, and secondary storage is the volumes and a tape, everything where you store the data. And we have the logical record, which is a basic unit of the information used in a processing program. So the programs which you use, the information which is stored in the data set can be used for programming purpose, can be used for printing purpose, which is used for transactions, for everything. So the basic definition of data set is the collection of logical records which are organized in block structures and which can be kept in a storage, a primary storage or a secondary storage. We can define a data set as a data is organized in various logical records and block structures is called data sets, or a data set is collection of logically related data records stored on one or set of volumes. After definition, we are seeing how to name a dataset. A dataset can be many segments, like one segment or more than one segment. It can go up to 22 segments. So each segment has its own level of qualification. So here the example is my own dataset name. Here the first segment is a high level qualifier. So each segment, as I told you, has each level of qualification. And the last one is called low level qualifier. So this is how a dataset is named, means a file is named in a mainframe which is separated by a periods, and which will be having a different segments. Each separation between a period is called a segment, and each segment, and you can have 1 to 22 segments maximum. When it is a one segment, you call it unqualified segment. When it is more than one segment, it qualifies and it is called a qualified name, and it will be having different levels of qualification. While naming a dataset, we have different rules. Okay, so while creating or naming it, you have to follow certain types of rules. Here the first rule is a dataset name can be one segment or series of joint name segments, as I told you, qualifiers, and which should be separated by a period. Like this is an example. So the basic dataset is one segment or two segments which should be separated by a period. And the next rule is a dataset name cannot be longer than 44 characters. Out of that, 22 segments can be there. So how it can be 22 is, means normally a dataset name should be 44 characters including the full stops, means including the periods which you are keeping in between. And as you know, 44 divided by 2 is 22, so you can give 22 periods and 22 alphabets like this. But mostly no one follows this naming convention. Mostly you follow the above naming convention with 44 characters with periods separated by the high level qualifiers and low level qualifiers. And the next rule is that one segment should be only 8 characteristic length, means whatever you are putting between a periods, it should be only 8 characters length. If it should not be more than 8 characters. And a dataset cannot contain two successive periods or end with a period. So you should not put two periods in between two qualifiers, or it should not end with a period. Then it will be a wrong naming convention. And the next rule is the first character of the segment should be alphabet or the special characters that are #, @ and $.
Means if you are putting 2 segments or 3 segments, how many segments you are putting, make sure the first letter should be alphabet or hash at $10, not a number. If you are putting a number on the start, it will not take as a dataset name. And the next rule is you can put number anywhere else in the segment. Means in the segment, remaining part can be number, hash, hyphen, at, dollar, and a letter. So, but the restriction is only to the first letter of the data set. Till now, I explained how we create a data set and what is a data set and naming conventions of data set. But there are many types of data set according to the requirement in the mainframe. So, it's like 2 types. The main 2 types are non-VSAM and VSAM, and under that we have 3 and 4 types. Like non-VSAM types are physical sequential, PDS and PDSE, and the VSAM are entry sequence dataset, key sequence dataset, linear dataset, relative record dataset. Non-VSAM dataset types part 1. The first type was non-VSAM types. So in this, the datasets can be divided into 2 parts, that is sequential, which is physical sequential, and partitioned, which is partition organized. In partition, we have 2 types, that is partition dataset and partition dataset extended. First and a basic file is physical sequential dataset. It's a basic flat file in mainframe. Like it's like a normal file, which means like how do you write in a file? When you write it one after other, like one line after other, one line after other. Even if you scratch some line above, you cannot rewrite on that line, right? So it's one after other. So it's a simple file with records stored in the order that they are written. Means it's like if you see here, so if this is the first record, so the second record, if it is written, it will go here. Third record, it is written here. Fourth is, if even this record is deleted, the means the next created will not be next entered record will not go here. So the next entered record will come here, 5th one, 6th one, 7th one. Even it is deleted, that place will be empty like that. It will be empty, and but it won't be used by the new coming records. So the new records are appended at the end of the data set. It means whatever you are writing, whatever the new data is going into the data set, it will go at the end of the data set. So maximum this file can be in one volume. It's a basic data set, will be there in a one volume, and it can go up to 16 extents. I'll explain you what is extents in upcoming video, but it can go up to 16 extents in one volume. And this file has an attribute of extending up to 59 volumes. Means if you're creating a file with a more space, then it will go to 59 volumes. It can take up to 59 volumes of space, in which it can take up to 944 extents. Remember this word extents and volume. I'll tell you how this will be spanned and how it will be expanded in those volumes. And here we have another type called an extended. When there is a word called extended, normal data set will take only 16 extents. Like I have mentioned here, it will be taking only 16 extents in one volume. But when it comes to an extended data set, it can go up to 123 extents. Remember the word extents, I'll explain you in the next video. So it will go up to maximum of 123 extents on each volume. But the physical sequential, it will go up to only one volume. So physical sequential extended can span up to 59 volumes with 123 extents, which is 7257 extents. Okay, so physical data set can go beyond. See, normally when you create a data set of normal physical data set, it takes 65,535 tracks. Okay, but when it is an extended data set, it can go beyond 65,535. Next file is partitioned file, partition data set. Okay, so this is so it is like a library. So we see the library, how the library will be. Think this is a library. So in that, how the books will be ordered. Think you have each row, this is of history, economics, politics. So like there is a different books, and in that books you'll be having some data. So here in PDS files, so the PDS files will be having a members inside them. So names are different names inside them. So with that name, inside that names you have this PS files. Like the data is like PS files. Like I have told you before, the data will be stored or appended in the end of the record, like one after other the data will be entered. So in PDS file you will be having PS files, but they will be like members. It will be like a big library which will be having a single name. With that name you can access to different members. You can create, okay, you can, so see, a directory of a sequentially organized members, each of which contains sequentially organized data. So you can create the members inside them, inside each inside each data set. Then after that you can access that members, and it's like a set of members you can put in one data set, like one file. It's like how a set of history books are kept in one rack. It's like that. So it contains members in the data sets. Like I told you, each data set will be having a members, and each individual member can be accessed without searching the entire data set. Yes. So how can you search is, once you go into one PDS member and you just give find F space the member you need. Okay, there's no need of searching one by one. You just give F space the member you need, or L space. It's like F space the member you need, or L space the member you need. So it'll automatically locate the file where the file is. So members are like how many members you can create in one PDS file. If that is a question, how many you can create by a formula which is called 6n minus 1. The 6n here n is like if you need 50 members, 6n minus 1. Like suppose if 6 5s 30, 30 minus 1. So if you give n equals to 5, if n is equals to 5, you will be creating 6 5s 30 minus 1. It's like 29 members. So if you are giving, while creating a PDS file, it will be asking you how many directory blocks you need. So in this directory blocks number is n. So if you, while creating data set, if you give directory blocks as 6, then that in that PDS or in that library you can put 6 6 or 36 minus 1 means 35 members you can create in that PDS. So this data set will be there in only one volume. It cannot extend more than one volume. Like I told you, in PS can be shared up to 59 volumes, but when it comes to PDS, it can stay in only one volume, and in one volume it can go up to only 16 extents. So the partition dataset, the PDS dataset, what I'm saying, it has some advantages and disadvantages. Okay, so the advantages are, you can find the history book in the history rack and the physics book in the physics rack. It means you just need to know the rack name, where it is. So you can easily group a set of data sets under a single name. Okay, so it's like how I told you before, there will be one file created, that under that you will be having a members according to the n or the directory block which you specified, and you will be having the members in it. Okay, so this members can be, the next advantage is, can be lesser than a track. Means when you are creating a PS file, which I told you before, PS file, you give a particular space. Okay, I'll explain you what is a track, how many bytes it is, how much space it is in an upcoming video. But when I'm saying you give some particular tracks to create a PS file, but when it comes to a PDS file, you can simply create a small data sets, like PS files inside PDS file, in which you can simply write just hi, nothing more than that, and just here you can write just bye, like that, because you will be this big data set is already given a space, and in that space you are voluntarily creating this data sets, this small members. So this, you don't need to specify any name. You can make this files bigger and you can make them smaller. But when it comes to a PS file, what happens? A PS file, while creating, you give that, okay, this file can be 1 GB. So when you say this file can be 1 GB, it will be only 1 GB. But when it comes to members, if you have given this PDS member as 20 GB, if you have given this PDS member a 20 GB of space, so this members here, it can be 1 GB, it can be 2 GB, it can be 10 MB, it can be 3 MB. You can create up to 1 byte also. It can be 1 byte. So like that, it's an advantage. Smaller than a track can be allocated. So the next advantage is multiple PDS can be concatenated. The word here concatenated means, suppose if you have two PDS files, okay, two PDS files, this have some 20 members and this PDS file is having some 5 members, and you want this two racks to be mixed, you want this two files to be mixed. Okay, this, you have this ability that you can mix this two files, you can mix this 5 files into this 5 members into this 20 members, so you can concatenate two PDS files. If these two are concatenated, it will take this. If you want this name to be the first name, you give this name in the top and you say that, or you can concatenate up to 5 to 6 files. How many PDS files? Depending on this file's directory blocks. Suppose this file is having a directory blocks of 10, which means 6 times 10, 60 minus 1 means it can hold up to 59 members. Suppose if you want to enter 5 some other member with some 20 and other member with some 4, and you want all this to be mixed up to this member, you can simply do a concatenation. There is a job, there is a program which you can run, and after running that program, all these members can go into this. If suppose if you are moving more members than 59, it won't accept. But if you are moving up to 59, the concatenation will work and you can pile up all the members in one PDS data set. Okay, the next advantage is you can easily create this file using our ISPF panel. I'll tell you what is an ISPF panel, which is a mainframe panel, a basic mainframe panel, or with a JCL, which means the program code which we use in mainframe, which is called JCL. You can easily create it. Okay, now we'll discuss what are the disadvantages. So the disadvantages are wasted space. How? So if you're creating a PDS and you're giving n, that is our directory block, equals to 20, so you're requesting a space of 6 times 20 minus 1, 6 choose 120 minus 1, that is 119. So you are requesting 119 of directory blocks of space, and you are also allocate with some GB of space. Then what happens? So all these directory blocks and all this space what you have allocated will be wasted if you are not using that space. If you have created some, if you have asked for some 20 GB of space, and this all space will be wasted. It will be just waiting there, or that space is like created and it's like waiting there for data to come, and that cannot be used by any other data set or any other file. So the next one is limited directory size. So as I told you, if you have given 9, as I told you here, if it is 59, you cannot go beyond 59. You cannot create a 60th member in it. You can create only 59 members in it. You cannot create 60, 61, 62. It's like if you have given directory blocks as 2, you can create only 6 to 12 minus 1. That is 11 files. That's it. 11 members in it. So lengthy directory search. As I told you before, if you want to search something in the member, you have to give F space the member name, L space the member name. But how the members are aligned or how the members are arranged in a PDS is they are arranged in an alphabetical order. So one after other, they are in an alphabetical order. So when you are searching, when you have given L space the particular member name, how it will search as an interpreter? It searches after 1, 1, 1. Suppose if that is having n equals to 20 and a bigger directory block with 119 members, it has more members, then it will, if you are given something which starts with Z, just example, just think it will search on each member, and it will take up at least 5 seconds or 6 seconds to give you that that member name. So it takes a lengthy directory search. The last non-VSAM dataset is partition dataset extended. So as I've told you before, we have some disadvantages with PDS file. Think this is a PDS file, okay, and these are the entries in PDS file. So members, like these are the members which are getting created, and think that this member is deleted and this member is deleted and this member is deleted. But when a new entry comes, it doesn't go to this place. It will be added at the end of the, like as I told you, it will be appended at the end of the dataset. So new datasets will be, new members will be appended here, like it's a sequential entries. So as it is a sequential entries, it will be coming here. And as I already told you, it has a n equals to directory block parameter is there. So what happens if n is equals to 2 or 3 and only that many members, as I told you 6n minus 1, only that many members you can create in that particular PDS member. But coming to this extended format, we do not have that issue. It can PDS which does not have a fixed size directory, it can is an unlimited, it has a limit but it's not a small number, it's a big number, and can reuse deleted space. So if this space is deleted, this space is deleted, this, it will go here. The new files will be coming into this place. Even in PDS, we have a program to get this deleted or free space by using, we have to do reorg, that is reorganization of the data, or compression. There are two codings which we can do and with which we can reuse this space, but not automatically. It will not be done automatically. But in PDSC, we can, the new members will be added in the deleted members place. And the next one is, they also have a better facilities of data sharing. So what happens is, if this is a PDS file, and if me being a user 1 and someone is a user 2, if two users are using this data, I can create a member here and the other user can also create a member here. Means this file can be used by as many people as possible. Means the data sharing is possible. But when it comes to PDS, there will be a contention. It will say that someone is holding this file. So it will be saying that when you open, or if you want to do some process in those file, it will not allow you to do that. And PDSC stores programs as a program object. Okay, so what is program object here is, the PDSC stores the data, whatever data you have in it, as an object form. Okay, but coming to PDS files, it will store as a load modules. Okay, as one by one load modules it will be storing, and the PDSC stores in a program object type. And as I told you, it's an extended, and but as it's an extended, it can go up to 123 extents in single volume, and a PDSC can be there only in one volume. It's unlike like PS, it won't be there in 59 volumes, but it can extend up to only one volume, but 123 extents. It can go up to 123 extents. And as I told you, the single file, normally a file will be in one volume. If it is getting created, it will be only 65,535 tracks, but PDSC can go more than 65,535 tracks and 123 extents in a single volume. And as I told you, an unlimited fixed, it's not a fixed size directory. A single PDSC can have these many members. It's 5,22,236 members. Mostly we don't create that many of members, but so that is why it is portrayed as an unlimited members of, compared to PDS, we can create an unlimited members in PDSC.
A non-VSAM dataset, there are some specifications or attributes which we have to know to create a non-VSAM dataset. So I'll be explaining you what are some of the attributes of a non-VSAM dataset in this particular video. To create a basic dataset, we need to fill some of the details before giving an enter or before creating a dataset. So here we have space units, we have data class, device type, volume serial, storage class, and management class. Normally, for a basic dataset, when we create it, we give a basic units that are, we give space unit that are blocks, tracks or cylinders, we give that, and we give primary space quantity, secondary space quantity, directory blocks if it is a PDS file, and we give a record format, which type of the file you should be creating, like which type of file you need, what type of file is an input file, what type of file is an output file, and what type of file it is taking, if it is taking as an input, means if it is taking as data, and record length of that file, block size of that file, and which type of file you're creating, like library, PDS, a normal PS file. So these are the basic informations which you have to give while creating a data set, a basic non-VSAM data set. So today I'll explain you what is record format in this video. As I told you, we'll learn about record format, but before learning about record format, we have to know what is block size. So consider this is a data, okay? This is a data, and you will be data with, this is a set of data, means, and the data will be going into this like this, one by one, one by one, one by one. Then again a new data will be coming, and again a new data will be coming, like one by one when data is coming. It, what is the maximum length of one data, like what is the maximum size of one data is block size. So maximum length in bytes of a data block is block size, means if data is some 20 bytes, that would be its block size. If data is some 10 bytes, that would be its block size. So like that. So what is the maximum? So maximum size of a data is the block size. Okay. So the must must be a multiple of record size and no more than 3. So remember that the maximum of data can be only 32,760 bytes. Okay, so 32,765 is the maximum bytes of data, means at a one set of data can go into a data set at once, means that is a packet, that packet of data can go into one data set. So okay, when there is block C, block size is inversely proportional to the input output, so IOs. Okay, so how it will be is, if the block size, if the block size is more, okay, if the block size is more, there won't be a, if the data is more, there won't be a more input output transactions happening. Okay, so it will be easier for IOs or the devices to be taking the data easily. If the block size is less, okay, when if the block size is less, what happens, more IOs has to be taken, more times you have to call the dash d, more times you have to call the volumes, more time you have to put the data in it, or taking out the data or putting out the data, anything. If the block size, if the data block is a bigger one, only at a one stretch you can get out the data out of the volume. Okay, so and the limitation is block size should not be more than a 2 GB. So other one here is record length. It is a part of a block size. So as I told you, if this is the data block, if this is a data block will be having records in it. Means if the data is going into a data block, this is a part of one record, this is one record, this is one record, like that. If this is a data block, in that we'll be having a parts called record. So the basic unit in a data block would be a record. So that length, this length which defines, with this length is record length, means while creating a data set, means while creating a normal data set or PS or PDS or any of the data sets, we will be specifying these values. We want, it's like example, simply we want the block size should be this much, means the data block should be this much size, and the data in it, means the records in it, should be this many bytes, like that. While specifying or creating a data set, we give that information in it. So now you have known what is record length and what is block size. Now the next thing you have to know is how the records are being arranged in a block. That is what is a record format, which describes the way of records organized. So think that this is a data block, which is a block. Okay, and the records can be all of same size, and if this is a data block, records can be of different size. One could be a smaller one could be a bigger one could be so smaller one, and there's another chance where a block size would be an equals to a record length. It can be a block size, it can be a record length. The same size of a record which is equals to a block size. So there are many types. Okay, as I told you, the blocking, why we are doing blocking. So the basic unit is record. So the data we get in a record format only. But why we are mixing up the records to make one block? So the blocking helps us with an input output processing, so that the DASD or so the devices it would process faster. So that is the reason we do a faster for faster processing we do this blocking thing, so that the more data could go at one at a time into the into means outside to the transaction or into the device or outside to the device. So whatever the transactions happening, if there is a blocking process is there, means the setting up, means if more records are set up in a block, that would be an easy IO transactions happening. That's the reason we are doing this blocking thing. Okay, and another reason is there are how means how a file needs an input, means different files needs an input in a different way. Some may need a lump sum of data, some may need a less data, some data would be very small and some data would be very big. So in that way we could add up all the records to make one block. So here we have some types which are fixed, second variable, third undefined. So there could be a fixed blocking, there could be a variable blocking, and an undefined one. So we'll see. Here comes the first type in the record format, that is fixed. As I told you, there could be a blocks where the record length would be equals to the block size. In the fixed, it is same. If this is a record, and that would be equals to block, and record and block are same, means the data packets, whatever the data packets you're getting, the same data packets would be a block size and record. Means when you're specifying f fixed, means while there you don't give fixed in that panel where I showed you before, you have to give f. So if you're giving f, and if you're giving that f as 80, and the blocks will also be, means if you're giving record length as 80 and the block size will also be 80, means if the data, whatever the data is coming into the volume or into the device where you're storing the data, there the record length and the block size will be more, it will be equal, and which implies that IOs will be more, because less record length, so more IOs. So we prefer this less. So next comes fixed block. So that here, as I told you, we are blocking, means we are grouping up some of the records. So here it is like this is a blocks and these are the records of same size. All are of same size. All blocks, all records will be of same size. And here how the math works is, if the record length is 80, then if suppose this is the block, think that the record length is 80 and the block size you should specify as multiples of 80. That is, it could be 2 which gives 160, it could be 3 which gives 240, so like that. So if you are specifying FB as a record format, and you should specify, and you will specify record length as 80, and um, the block size should be multiples of 80. It should be 160, 240, 800, 8000, whatever you're giving, it should be multiple of 80. And here as this is a fixed block, here the data set will be in blocks and fixed, right? So whatever, see this, and data will be coming is, suppose you have example, you have specified 80 here,
Example, how the math works is, suppose if you have specified record length as 80, so think that this is the data block. Okay, so this you have specified 80 as record length and block size as 160. So this block size will be 160 bytes, and which will be taking two records, that would be 80, 80. And the next pack, the data pack will be coming like this again, 160 block size with two records, 80, 80. Again third, in the same manner. So here the you will be getting data in a fixed block of 160 bytes data. Okay, so and we have a disadvantage here. The disadvantage here is, suppose if this is your block size and you are writing data in it, and you need only 45 lines of data, and you wrote till 45, and this remaining space, whatever this remaining space is there, it is wasted. You cannot use this space. Means again, if the next data is coming, it will go here and again. So the next record will start with another. So if the data is coming, it will come in another fixed block size. So that's how a fixed and the fixed block record format will work. Next type of record format is variable. In variable, the block size, like previously we mentioned, the block size is 80 and the record length should be 80. It's and the all the data whatever coming into the devices will be in the same format. But here it's not like that. If the first block is of 80 and the second will be 90 and third will be 100 and fourth will be less than 100, it could be a 90, like that. So and here we have something called record descriptor word. So normally what I told you, the maximum is 32760, but the maximum of the record length will be 32760. But in the variable, here we have to mention that there is another type. Here we have something called RDW, record descriptor word, which will take first 4 bytes of the block or the record. As here the block size will be equals to a record size in a variable, but so here it will be RDW of 4 bytes, and in 4 bytes the first 2 bytes will be the record length. Whatever the length of this record will be mentioned in the first 2 bytes, and the next 2 bytes will be 0, 0, 0. That will be for spanned records. Okay, so this is for 0, 0, and this first will be consisting, this is RDW, it will be consisting record length. Okay, so what is the length of that block will be there in it. And another type here is variable block. Means here also there is a block data, but this block data will be of different sizes, but the data will be blocked inside. So it would be like this. Suppose this is a block data, and in this the data could be a smaller one, a bigger one, a smaller one. So it means the block size is not fixed like before. Here it is a variable blocks, variable records, sorry, this will be a variable records. And if the next one could be, suppose this is 160 bytes and the next one would be some 150 bytes. Okay, it will be like that. And here we have another parameter called block descriptor word, which is again 4 bytes. The first 4 bytes of a block will be a BDW, which will in which we have two types. One is extended and another one is non-extended. In extended, the first byte will be 0 and the next 2 bytes will be block length, and the last byte will be zeros, all zeros. Okay, and in non-extended the first byte will be 1. Okay, and the next all bytes will be the record length. So here, that is why if you see the bytes are, we have bytes are 32756 is the maximum bytes here. The reason why here is 32756 is the first 4 bytes are fixed for BDW. Okay, here comes the last record format, that is undefined. So this doesn't have any fixed means this doesn't have any RDW or BDW or a fixed block block size or record length. So here the block sizes would be, if this is one block, and the block size would be equals to record length. So if this is one block and another block, if suppose this is some 80 bytes a block, and the next one would be an 100, a next one would be a 120, a next one would be a 90, a next one would be again an 80. So there isn't any proper defining for this. So normally this undefined is used for a load libraries and the object modules. These load libraries are some libraries which are not, you cannot define the size of those libraries. Okay, these are system files where the most system files will be there, which could extend inside, which could extend more, more data can go into it, more extension could happen. So at that time, so you cannot consist it to a particular size. You cannot ask it that file to be in this particular size. Then you define the particular files in an undefined format. This is a small picturization of how the record formats are. So if you see here, this is a only fixed record format, in which we know that the record size is equals to, sorry, block size is equals to record length. So if you see, all the record lengths are equals to block size in it. The next comes a fixed block, where we know that the block size is an integral multiple of the record length. So the block size, if you take the block size as, sorry, if you take the record length as 80, then the block size would be n into 80. So it would be like that. And why I am saying 80, 80, 80 again, because the minimum length of a block L record, the record length would be 80. So just remember that the minimum length would be an 80. Then again comes a variable, where you know that the first 4 bytes are for the RDW, record descriptor word. So the first four, after that, then less the data length is the record length. So it will be sometimes equals to the block size, and it could be less than block size. So they are different. And after that we have variable block, where the data is again blocked, and you have 4 plus n, because it will be having RDW and BDW also. It will be having a block descriptor words and all, and record descriptor word also. So that is why if you see here, it is defined as 4 plus n into record length. Okay, and the last one is undefined. It can be in any method. It could be bigger records or smaller records, bigger blocks, smaller blocks. So that's how it ends. Now, allocation, how a space is calculated, how much space you give while creating a data set, and how it is getting allocated while the data set is being created. So this is a panel where you give the space attributes when you're creating through a panel wise, when you're creating a data set through a panel wise. Now I'll explain you about the primary quantity, average record unit, secondary quantity, directory blocks. Like how much you give, how it is getting allocated, and space units also. And space units, what is a block, what is track, what is cylinders, how much KB they are, how much MB they are, like how you give each and every point, and how they get calculated when you give some certain numbers in those places. The data set attributes which we are seeing now, as I told you, space allocation, space parameters. There are many types in like how you give a space. Like there is units, like how you weigh something, kgs, grams, like that. Here you have another unit called tracks, cylinders. It's the basic calculation here is one track is equals to 56 kb, and one cylinder is equals to 15 tracks. 15 tracks. Okay. So you specify which type of, like, you need something in grams, you need something in kilograms, something you need in milligrams. Like when you buy something from grocery store, you take it like that, in that way. So in the same way, when you're allocating a data set with some space, you say I need it in tracks, I need it in cylinders. That's how, if there is a volume, if it's a tape volume, if it is a DASD volume, it takes the allocation in the volume starts like that. It's, if you are asking it for tracks, it will allocate in the track wise. As I told you, what is a block before, a fixed block, variable block, how the blocks will be. If you want that space in blocks, you give that average block length. Means this, I need my block length to be 300 bytes, I need my block length to be this much. Like that, you specify some number like 300 bytes or 1000, like 10, 20, 30, like that. You'll specify number for blocks. And when it comes to records, you have three types here. When you're because when you're creating in records, when you specify records, you have to give an average record length. There is another attribute which, when you're only specifying records, you have to give that attribute. It says like UKM. There will be three separate parameters here. I'll explain you later. But so these are the basic space units which you see, like tracks, cylinders. Normally you mostly create a data set in tracks and cylinders. Not, and if there is some variable data set, you want data set to be particularly in this length, in this type, or, and if the input data set is like that and the output data, according to the requirement, the records and blocks come into picture. But mostly if you're creating a data set, you give tracks or cylinders. Here is the basic. The next quantity is called primary quantity. Like if your data set need 300 tracks, okay, if your data set needs some 1000 cylinders, so you say my primary quantity is 300. When you first say that I need, my space unit should be track and my primary quantity should be 300, then when you're creating a data set, the initial allocation, as soon as the data set is getting created, it automatically gets that 300 tracks. It will get, if you're using that 300 tracks, if you're not using that 300 tracks, it doesn't matter. It automatically gives you that 300 tracks. Take it, this is the space which you have allocated. That's what a primary quantity means. If you're specifying cylinders as a space unit and you say I need 1000 cylinders of space, and you just go in the primary quantity should be, then automatically this 1000 cylinders will be occupied in one volume. Means, see, there are some constraints here. Like if you are specifying 1000 cylinders, there should be this continuous space available in that particular volume, because the primary quantity is something. Suppose if you're giving primary quantity equals to 100, if there is a volume in which there is space, but suppose there is space of 500 tracks, 500 tracks of space is there, but it is not continuous, then this will not allocate this space. When you're saying primary quantity 50 or 100, that should be a continuous space which you need in a particular volume to be allocated. Then comes into picture secondary quantity. If the data set needs more space, like there is a small allocation, when you're creating through a code, you say space is equals to, I need it in tracks, and you say primary quantity is 100, and you say secondary quantity is 50. So this is how you allocate when you're doing through coding. So you say this is primary quantity, this is secondary quantity, this is a space unit. This is how I need 100 tracks initial allocation. As soon as the data set is creating, the volume gives you tuck 100 tracks to you. And but what is this 50 tracks then? Why this 50 tracks is needed? Okay, so when the data set, you want the data set to be extended, you want, as I told you, a word, if you remember, extend. When you want your data set to be extend, it's not, if 100 tracks is not enough for the data set, you need more tracks. Then the secondary allocation comes into picture. You this When after 100 tracks, what happens? It takes, if you need another next one-on-one track, what it will do? It will ask a secondary, it will take one space from here. So 100 plus 50. If after this 150 tracks is completed, again it says I need another one, my data set has to extend more, I need more space, again you will get 50. And here the question is, how many times this 50 will be added? It depends on the dataset type. As I told you, how many maximum extents a dataset can extend. If it is a PDS file, it can go up to 123 extents. If it's a PS file on a single volume, it can go up to 16. So it depends on if suppose you're creating a simple basic PS file on a single volume, suppose if you're giving this much space, it will be like 100 plus 50 into 16. So this is the whole space which it will be created. That much of tracks it will take. It's like 16 5 800 plus 100. So completely 900. 900 tracks it will give, like if complete one volume. And depends, as I told you, I'll tell you how many extents a maximum, how many maximum extents a data set can reach. In that way, as that many times the secondary extent will give you the space. If it is 16, it will give you 16 times. If it is 123, it will give you 123 times. If it is 255, it will give you 255 times. So that many times the secondary space can be giving you in this space unit. If you say it is I need in tracks, it will give you 50 tracks. If it say I need in cylinders, it will give you 50 cylinders. It should not be continuous space. There is no need that to be a continuous space. Only the primary space should be, when you're giving some 100 tracks, when you're giving some 200 tracks, the primary space should be a continuous space. Means when there would be some errors, basic errors, which we say SB37, SD37, SE37. These are the basic errors which you encounter when the space issue comes. I'll explain you these errors properly in the next video. So that's how it will be the primary quantity and secondary quantity. When you're creating a basic PS file, you have to be so sure how much primary quantity you're giving, how much secondary quantity you're giving according to the requirement. Here comes the next parameter, which is, as I told you, primary, secondary. Primary, secondary is enough for the PS file, a basic flat file. That is enough, right? But what about the PDS file, which need members? And how do you tell how many members does it need? That's how, by 6n minus 1. Suppose if you're creating, you say, as I told you, you can put all group of data sets in one place, right? If you say I need 50 files in that, I need in one data set, you create a data set with this name abc.abc, and you say I need 50 members in it. So that how can you say what is the directory block you can give? Suppose you need 50, you give 9, 6 and minus 1, right? 6, you give directory blocks n is equals to 9. Okay, so n equals to 9. When then it will be like 54 minus 1, it will be 53. Then you can create 53 members in it. So it depends on according to the requirement, like how you can give in the space is equals to the space unit. You say I need in tracks, and you say the primary quantity is 100 and secondary is 50, and I need directory blocks as 9. So this is the third parameter where you give 9. This is directory block, this is secondary quantity, this is primary quantity, this is space unit. So that's how you specifies in a code. And while you're creating through a panel, you give in the panel where it says directory blocks, you give 9, saying that I need 50. If you need 50, it depends on the requirement. If you need 100, you give another number. It depends on requirement, how many members you want to create in that type. You give this is the number I need. So this is the number I can give as an indirectory block. Like I told you, if you need a 53, if you need 50, you say I need 15 members, 50 members. Then you say directory blocks equals to 9, and it gets calculated by 6 and minus 1. So here's the next one, which is average record unit. So when you specify, as I told you, space is equals to, you give here space unit. But when you specify space unit instead of tracks, cylinders, if you have specified records or blocks, you have to specify this average record unit should U, K, or M. If it is U, it is a scale of 1. If it's K, it's 1024, and if it's M, it is 1048576. Okay, so how this is calculated? As I told you, okay, when it is track, it is 56 KB. Okay, when it is cylinders, it is one track is equals to one cylinder is equals to 15 tracks. Okay, 15 tracks. But what about this calculation? How records and blocks are calculated? So when here, how it works is you give space is equals to, you say space is equals to, you suppose you need your record length, your average. You give here the average block size or average record length, how much you need. Like I told you, like fixed block or fixed. If it is block, you give blocks, right? There, if suppose you give, if say I need 80, and you say primary as 50 and secondary as some 2, and this is how you have given the space unit here when you have mentioned 80. And now you have to specify another parameter which is called avg rec, that is average record. That should be instead of u, k, m or anything. Suppose I have specified k here, avg rec is equals to k. How it is getting calculated? Now when I say it is tracks, it comes under 56 kb, 15 1 centimeter equals to 15. When it is like this, it is like avg rec is k, right? K means 1024. So how it is getting calculated? You say 80 into 50 into 1024 is the primary quantity. And coming to secondary quantity will be 80 into 2 into 1024. Okay, so it comes in that way. So this is how this much of primary quantity will be allocated at once, and this much of secondary quantity will be held when it is required. So that's how average record unit is specified when you're giving records or blocks or record or blocks, and you have to specify this parameter called average rec, so that it knows how it has to be calculated and how much like if it has to be 1024, if it's 1, or it should be 1048576. And here's another, the last one, normally which is not required when you're creating through code, but when you're creating through panels, you have to mention if it is a library, if it's a PDS or the large or the basic. Basic is not required, but normally in the last you have to mention whether this is a PDS file. It lasts, there's a dataset organization, there is a sentence, there is a filling for dataset organization. You can give here library, PDS, large, basic, anything when according to the requirement. But when you're creating through a job or through a program, there is no need of giving this dataset organization always. Sometimes if it is required, you want your dataset to be particularly in that time, in that type for that input file. So means for that requirement of or for that application, then you have to mention DO. It says DO. DO is equals to PO or PS or like this large or PDS, like that you have to mention. So these are the basic dataset attributes which I have mentioned past two videos. In this video I've explained you all the specifications which all the basic specifications which you can be using to create a basic dataset without any fail with this basic requirements. So in the next video I'll explain you how to create a dataset through using a panels, how you give the values and how you have to see where it got created and how can you analyze the data in it, and explain you how to basically create a data set. So thank you for watching the video. Please kindly share, like and subscribe.